Hello, and welcome to my video tutorial on how to create your own functional first-person controller in Unity. Over the course of the next 10 minutes, I will cover the process of setting up a playable character, creating a functional camera for the player, and allowing the player to navigate the game world. As someone with a beginner's understanding of code, the aim is to introduce the subject in a manner that anyone can follow along and start making their own video game after watching this tutorial. Timestamps are available in the description if you would like to skip to a certain section, and be sure to slow down or even stop the video if you need more time on the subject. With that being said, let's begin. Go to unity.com and click the Get Started button. Select First-Time Users. This will take you to the payment plan page. Choose either Student or Personal to continue. Create a username and password. This account also lets you post and upload to the forums. Be sure to sign up for email alerts to hear about the latest engine updates. Now that Unity is installed, it is time to create your first project. Open the Unity Hub and under Projects, select New. Name your project, and once created, click on the project to open it. Setting up the player. While an object such as a cube or rectangle seems ideal for the player, the capsule's narrow shape and rounded ends allow for easier transitions up and down slopes, and a curved hitbox allows for better collision with geometry. To add a capsule, click the Game Object tab at the top of Unity. Move your cursor over the 3D Object tab to reveal the objects you can spawn. Select Capsule, and in the World Viewer, your new object should sit in the middle of your screen. You might notice 3 colored arrows jutting out from the center of your capsule. These move the capsule in their corresponding directions and adjust themselves according to where you view the object. With the capsule created, mark it as your player so it is easily identified by Unity. To tag an object, click on the capsule and go to the inspector on the right side of the screen. Underneath the object's name, click the Tag menu and select Player. From here on out, anything you want connected to the player will be associated with this tag. Adding a camera. Think about how you use a mouse. Dragging up moves the cursor up, dragging down moves the cursor down. The same thing applies with moving left and right. We need to apply this concept to the player's eyes and body to get a full perspective of the game world. First, add a camera to the capsule and move it up to your liking. Do not set it too high because if there ends up being a ceiling above you, there's a small chance the camera will clip through the surface. Using C#, it is time to write the code that will let the player look around by grabbing the mouse inputs in the player's body. Be sure to set up a few static objects around your player as targets to test your controls. First, name your code mouseLook for easy reference. Create references to mouse sensitivity and player body, and assign these in the editor. Include a default X rotation value of 0. Lock the mouse cursor to your character's perspective and hide the cursor in-game. Write this inside void start to enable this function immediately. Get input values mouse X and mouse Y from your mouse. These formulas take mouse input, multiply it by mouse sensitivity, and multiply that amount by the duration of time the mouse is in movement. Apply X rotation limits to restrict the angles your player can observe the world. Use -90 and 90 degrees to look up and down without rotating beyond the capsule. Complete the code by rotating the capsule along its local position when looking around. Assigning the first-person controller. Drag and drop the character controller component onto the capsule. A side menu should pop up on the right side of the window. In your C# camera script, ensure both the camera and player are selected. Unity will not run if these slots are left vacant. Ensure step offset and min move distance is set to 0. Offset alters your initial move position and makes interactions such as jumping over objects difficult when altered. Experiment with other values. You can set the limit for inclines and adjust the size of your capsule hitbox. Adjust these settings to your liking once you have completed the basic first-person controller. Load up the game again. You should view the game world from the eyes of your player. Make sure to look completely up and down to ensure the restraints are working, in addition to swiveling around to ensure the player can rotate in a full circle. If the player turns too slowly, enter a higher value for the mouse sensitivity. You can adjust this value at any time, even while the game is running. Defining movement. The ground check is an invisible sphere that sits at the bottom of the player and checks everything inside it for the ground tag. Like the camera, right-click your player to create a new object. This time select Empty to create an invisible object. Open your first-person controller and drag it onto the player. We should also set up some basic shapes to walk around on. Tag any 3D object you want to walk on as ground, as this will be essential for the jump function. Unity sets itself apart by utilizing built-in input detection for keyboard and controllers. What we want to do is grab these universal inputs and use them to move the player. Vector 3's, X, Y, Z, are commands in C# that transforms an object along the X, Y, and Z planes. We want to assign these 3 directions, so pressing up moves you forward, down is back, space is up, etc. To do this, utilize the WASD and arrow keys as they come on a keyboard by default. Movement, velocity, and speed. Basic movement allows the player to navigate the game world, but is more involved than the mouse script. Write up your movement in C# and apply it to your character, grabbing inputs for both the X and Z axes. This establishes the ability to walk, and as the code progresses, movement speed and velocity are added to smooth out the player's movement. Grab inputs for both the X and Z axes. These are essential for the move function that other functions inside the code call upon. Create a basic formula called move. Multiply transform right by X and add transform forward by Z. This moves the player in the corresponding directions when the horizontal and vertical keys are touched. With basic movement established, apply it to the controller along with movement speed and input time as controller.move. Utilize controller.move again to add velocity, creating more realistic movement. With the code compiled, run the game. The player will move based on your inputs, but going up slopes or elevating the player will not bring them back down to floor level. Instead, you'll be trapped in the air with no way to get down, which means we need to add gravity. Implementing jump. Since the player gets stuck in the air when climbing up slopes, we need a way to not only fall but jump as well. In addition, while the player is on the ground, we want to stop the player's downward velocity from increasing infinitely. This is where the ground check comes in to stop that from happening. Go into your player movement C# script and make yourself some space. Since we already have a function in place that checks if the player is on the ground, we'll want to reference that ground check. So, when we press the jump button and we are on the ground, we'll increase the player's upward velocity for a set amount of time and add gravity to pull them back down. Load up the world. The player should gradually reset to the ground if you walk off an elevated object, and when standing on objects tagged as ground, pressing the spacebar allows the player to jump. If you cannot jump, ensure your floor is tagged correctly. Implementing crouch. There are a few different ways to conceptualize the crouching ability, but it's easiest to transform the capsule collider by shrinking its overall height. Like rotating the player with a mouse or moving up with the y-axis spacebar, we want to shrink the player while a certain key is held. We already have a body for our player with the capsule, so at the beginning of our code, let's add a character controller command and call it character collider. When the game starts, our cylinder's height is set to whatever value we choose, but to add crouch, we need to make it so when we hold a key down, the player's height temporarily decreases. Load up the game world again. While this crouch button is held, you will shrink in size and can navigate small spaces. When the button is released, you'll spring back up and return to normal height. Conclusion. So now what? You now have a fully customizable first-person perspective to adjust and expand upon. If you want to give your player a chance to move around, set up a small obstacle course to navigate and experiment with the player's abilities. Take note of what works and what does not. Does the player crouch as low as you like? Or do you think some features are a little too fast? Tweak the values in Unity and find the perfect fit for your game.